Hello Math 125 students. I'm going to try to summarize 7.2 briefly if I can, just in case you want a quick review or don't remember something from lecture. I'm not promising I'm going to do this for all the sections. This is just something I'm experimenting with. So ultimately, this is one page of my notes I didn't get to on Friday. So I thought I would just do this in a video, and then in doing so, I'd review a little bit. So ultimately, we learned how to do all these problems in section 7.2. It was just an organizational method. And basically the two ideas were substitution. If you ever forget, it's trying to set up substitution. And the four substitutions we talked about were substituting for sine, substituting for cosine, substituting for tangent, and substituting for secant. And the entire method was to try to make those things appear. Now, in order to make those things appear, in order for the substitution to work, you also need the derivative to appear. So if you miss this idea, this is the whole idea of the section, is we're going to do one of these four things. You do have to remember these derivatives to make this work. But if you do, then you can do this section. So that was it. Our goal was to make one of these four work. And then we talked about when they will work. And then there was one special case where we did the half-angle identities. And basically this is what we did. We do these for any time. We did this one anytime secant was even. And I have this summarized in the handout I gave in class. We did this whenever tangent was odd and there was at least one secant. We did this whenever cosine was odd. We did this whenever sine was odd. Sorry, this one's when cosine is odd. And this one when sine is odd. But I said in class that I don't remember it by looking at a table. And we do this whenever we have cosine and sine both even. And there was things you knew. You needed to know the three half-angle identities, and you needed to know for all of these, you needed to know sine squared of theta plus cosine squared of theta equals 1. That's how we did this one. And then we had to remember if you divide everything by cosine, you got tangent squared of theta. So you're learning all the essential tools to work with trig functions. So this is all you needed for these problems. And over here you needed that cosine squared of theta is 1/2 1 plus cosine of 2 theta, and sine squared of theta is 1/2. So with these alone, you have the ability to manipulate things enough to integrate any of these. So the real question is, do you know the first step? It should be fast. So here's an example of an odd sine. Here's an example of an odd cosine and an odd sine. We did one of these in class and we said, for these problems, both work, but it's usually better to pick the smaller one. Here's an example of an even, that's that other case, half angle. Here's an example of an even secant. Here's an example of an odd tangent. This one's an odd tangent as well, but probably easier. So some of these you can do them more than one way. Okay, so let's see if you can do the first step. Pause the video and try to do the first step. And now I'm going to go. So if you've paused and just said, can I do the first thing? So the first thing here is to pull out a sine. The first thing here is to pull out a cosine. The first thing on this one is to start using half-angle identities. And if it's a 4, you basically have to think of it as cosine squared times cosine squared. So there's two copies of this. So this is the messiest one, but it's also the one that requires the least amount of kind of cleverness. You just use the half-angle identity and then you expand. I don't know why I'm using theta. Let me fix this. I know the problem itself had an x. And we actually did this one in class. This takes a while. Right now I'm just focusing on the first step. You would then need to expand it out. This one has an even secant. So the first thing you're going to do is pull out secant squared. And then this one has a tangent that's odd. So you're going to pull out a secant tangent. So that's it. So we really should not have to think on these. Just if we have an odd sine or cosine, immediately pull out the first term. And then the whole point is that's going to leave a sine squared. And we're going to write sine squared is 1 minus cosine squared. and then there's still going to be a cosine to the fourth. Similarly with this one, after we pull out a cosine, that's going to leave a cosine squared. And so then we're going to copy down the sine, and that's going to be 1 minus sine squared. Similarly for this one, after we pull out two of these, we're going to be left with the secant squared. And all of these, we're trying to set it up. So if you didn't get this idea in class, this is the big thing I was saying, was that we're trying to set up a substitution. So if this were du, if this is part of my du, then I need everything else to be a cosine. If this is part of my u, then I need everything else to be a sine. If this is part of my u, then I need everything else to be a tangent. We're trying to set up so the substitution works. So this is already a tangent, so I'm not going to change it. But the secant squared needs to be changed, and secant squared is tangent squared plus 1. So we have tangent squared of x plus 1. So this is less math skill, it's just following the recipe. This one, after I pull it out, I'm going to have a tangent to the fourth. And unfortunately, I want them to all be secants. So how do I do that? I have to think of it as a tangent squared times a tangent squared, or a tangent squared squared. Tangent squared is secant squared of x minus 1 and squared. And now all of those problems are ready to go. So at this point, you just do the substitution. So this one's going to become the integral of 1 minus u squared u to the fourth. And it ends up, this one's going to be negative du because of that negative. So it's going to be negative 1 du. If you do the full substitution, I'm trying to be quick here. This is going to be u to the fifth. This is going to be 1 minus u squared du. This one doesn't have a negative. This one you're going to have to expand. Now it's going to take a little bit more work. This one's going to be the integral of u to the fifth, u squared plus 1 du. Done. This one's going to be the integral of u squared minus 1 squared du. And you are going to have to expand that out. All of these you'll have to expand and simplify. That's the idea of the section. Okay, that's the main thing. We did talk about some special cases in class. As you do the homework, you'll encounter a few things. You'll need the whole lecture for that. This is just a quick summary. So let's look at a few old exams. Here's a winter 2015 exam. So you can pause that and think about it more. Will you know how to do this? So you have to say, if I sat down to take the test, would I know how to start this question? You would say, well, that's odd. So the first thing we're going to do is we're going to pull out one of the sines. The next thing we're going to do is turn everything else into a cosine. And so you're going to have a sine squared, which will write 1 minus cosine squared. And then you'll do a substitution. Since this is a substitution problem, the easiest and cleanest way to do this is to change everything, including the bound. So you would say, all right, when I plug in a 0 to a cosine, I get 1. When I plug in pi over 2, I get 0. You want to practice getting better at trig values. It makes some of these things so much faster. 1 minus u squared, this is going to be negative 1 du. So this is negative the integral from 1 to 0, u to the fourth minus u to the sixth du. The negative I took out. Most people would switch the bounds and change the sign just because it looks prettier. And then you're almost done. We're almost done with this exam question. It's going to be 1/5 u to the 5, 1/7 u to the 7th from 0 to 1. So our final answer is going to be 1/5. So with practice, these are that fast. What would that be? 7/35 minus 5/35. So it's 2/35. I didn't even mean to do the whole problem. It just happened. We don't want to be surprised by that on the test. Let's keep looking. So here's another one you could pause it. This is the winter 2011 exam. Hey, that looks like an even secant. It also has an odd tangent. You could do it either way. In fact, I think I did this one on the previous page, so I won't do that again. What about this one? It's an even. Gonna have to do the half angle and work all that one all the way through. So this will happen on your next test. And we build on these ideas in the next section. So that's part of the reason I'm making this video is we need this. Sorry, there's a loud car outside. But we need this before we get into 7.3. Okay, hope that helps.